So hi everyone, this is the third video. This is the third session of SystemVerilog. So where we will see about literals, scalar, vectors, all those things we will see. Okay, in the last lecture, I told you about the variables data type, right? So in this video, I will tell you about the literals, scalar, and vectors. So first, we will see what is literals. So it is nothing but a rules that we will follow when we are assigning value to the variable. Okay, I hope you understand the what is variable, what is data type. So what is the literals? It is a rules followed in assigning value to the variable. Now, for example, you see here a string name. So can I write like this name VLSI Pro? It is wrong, right? We are not following the rules to assign the this value to the variable, string variable. So this is a wrong assignment. Now what is the right assignment? We will use double quote and inside that the string, that is VLSI Pro. Now this is the right assignment. Similarly, we have bit var. Var is a variable name. Okay, this is a variable name. This is the data type. Now var is equals to 2. This is wrong. Why wrong? Because it is a single bit. It's a single bit data type. So we cannot store this. To represent 2, we need 2 bits. So it's wrong. Now how we will write in a good manner? So var is equals to 1 tick. Now this one defines the size of this. So what is the size? Single bit. 1 bit size is there. So that is why I am saying 1 tick. This is telling this is going to be the 1 bit value. Now this B stand for binary. So 1 tick B 0 I am doing because I am going to assign the binary number. Again 1 tick B 1 I can do. So these are the right assignments. Note, if you do var is equals to 1, see I am using this representation, right? 1 tick B then 0 I am writing. If you directly write 0, so by default they will treat it as a decimal number, not binary number. So to make it binary, you have to use binary. To make it decimal, you have to use decimal. To make it octal, you have to use O. To make it hexadecimal, you have to use tick has. Okay, I hope you understand these things. Let's move to the next. Logic var1 is a variable name. Okay, and this is what you have three. This is what 2 down to 0. Okay, I will tell you this. We have one separate lecture for this size things. Okay, I will tell you. Just understand. We will read like 2 down to 0. So total 3-bit logic variable is there. Okay, so variable 1 size is 3-bit and that is logic type of data type. So var1 we can write like this 3 tick b 3 tick b 100. It's true. This is wrong, right? This is a 23 decimal and we cannot represent 23 using 3-bit. We can represent maximum 7 000 to 111. This is the maximum representation by using 3-bit. Okay, so I hope you understand what is literals. It's nothing but a rules which we follow when we are assigning value to the variable. Now let's talk about scalar. What is a scalar? It's a single bit variable. So any variable which can store only single bit and it is nothing but a scalar. What is that? Scalar is a single bit wire or reg variable. Okay, so bit. Now I told you this is a single bit, size is single bit a, reg also single bit a, wire this is also a single bit. Okay, and logic this is also a single bit. Okay, so can we make like suppose this is single bit, can we make multiple bit of bit can we make multiple bit of bit data type? Yes, it is true. Next lecture I will show you how we are doing, or even in this lecture only. So let's see, let's move further. And another we have vector. So vector is a multiple bit wire or edge which defines with a specific bit range. So it's nothing but a multiple bit data type which defined with a specific range. What is the range? I will tell you here. So see, it will define like this. So here they will mention something and here they will mention something. So using this you are defining the size. So read like how you will read like this. If you see this thing, then in Verilog we already seen this how to read this. So this is called as MSB, how we will read this? MSB down to LSB. Okay. So in example you see reg 9 down to 0. So this is 9 down to 0 A. Okay. So here A is a variable name. Okay, this is A is a variable name. Reg is a data type. So reg is a data type, and 9 down to 9 down to 9 down to 0 is a size of a variable. Now we need to calculate what is the size of a variable. Okay, data type we understand, right? It's a reg type of variable. What is the size? Like what is the size of this a? So in total size is 10 bits. Now we should understand how we will calculate the size. Okay, so we will understand here size calculation. How we will calculate the size? For that we have some example. We will go through that example. Then we will understand how we will calculate the size. So bit 9 down to 0 and bit vector. So this bit vector is a name of the variable, and the type of the variable is bit type. And what is the size? We will see how to calculate the size. So calculate the size, you need to follow one formula. What is the formula? Is MSB minus LSB plus 1. So it will give you the size. How? See, 9, this is your MSB, right? This 9 is MSB, this is LSB, this 0 is your LSB. So MSB minus LSB plus 1. Plus 1. So overall you will get 10 bits. Okay. Now we will see another example. So here you see logic VEC. Logic VEC is your variable name. Logic is a data type. So, and this is your size. So size is what? 23 down to 12. So in this case size is equals to 23 down to 12. Size is what? 23 minus, this is your MSB, right? 23 minus LSB. So LSB is your 12 plus 1. So you will get 12 bits. This is the size. This is the size. Now another example you see. What is the example here is regvec. So this is the variable name. This is the data type, and this is your MSB value, and this is an LSB value. So what you have to do is MSB value minus LSB value plus 1. So here 15 minus 10. So this is minus minus plus. So I am writing 15, and this minus will come here. So minus 10. So minus 10 plus 1. So overall it will come 6 bit. Okay. Now what is the meaning of size here? So I am saying size here. So you should understand what is the meaning of size here. So let's understand by some example. So bit A. So here bit is a data type. By default size is 1 bit. So 1 bit size is the size is 1 bit only. So what is the meaning of 1 bit is variable A can hold only 1 bit possible value. Okay, so 2 to the power 1 means how many possible value it will come? 0 and 1. This is the only two value which will be represented by 1 bit. Using 1 bit you can represent 0 or 1 only. So in this case, what is the size? MSB minus LSB plus 1. So 2 bit. Now how many value you can represent? So 2 to the power 2, because 2 bit is there, na? 2 to the power 2. So it will come 4. Okay, 4 value you can represent using 2 bit. So what are the 4 value? 0, 1, 2, 3. These are the value you can represent, right? Using 2 bit. So when we are saying this, it means what is the size? 3 bit, right? 3 bit size is there. Now using 3 bit, how many numbers you can represent? 2 to the power 3. That is 8 possible value it can hold. Means what? This variable, it can hold 8 possible value. What are those? 0, 1, 2, 3, 4, 5, 6, 7. These value, this variable can hold. Okay. More than that, if you put 8, this can't hold, because the size of this C is only 3 bit. I hope you understand this things. Okay guys, if you understand, just like the video and stay tuned for the next part 4 video, and just subscribe for the further content. Okay guys, bye.